Well, greetings, Mr. Kolazar's class. This is part 2 of section 11.5. You're going to have to write small to begin with today. You're going to just write this information down at the bottom of page 6 in your notes, so just decrease that font size. What we're going to look at doing today, just go ahead and hit pause so that I can just kind of continue on. But to write these 6 ideas down, first off, we're going to be converting all reactant amounts to products form, doing our mass, mole, mass. What we're going to be doing is looking at limiting reactant idea. So the limiting reactant is going to be one that produces the smaller amount. If you think back to like in our cookies lab, anytime one ingredient runs out or one reactant runs out, it's going to stop our reaction from taking place. Just like when you're driving in a car, when the gas runs out, it's a limiting reactant. It stops that chemical reaction for combustion from happening. The oxygen is our excess reactant. There's more than enough of that. The amount of product produced by the limiting reactant is the amount you can produce. The other reactant then is our excess reactant, and to find out how much excess reactant is left over afterwards, you're going to use the excess reactant used, subtracted from what you have, to figure out what's left over. So make sure you just have written all these at the bottom of page 6 before continuing. All right, now that we've written those down, we're going to look at the reaction between solid sodium and iron 3 oxide is one of a series of reactions to inflate an automobile airbag. So in our reaction, we've got 6 moles sodium to 1 mole iron oxide will produce 3 sodium oxides and 2 irons. If we have 100 grams of sodium, so if we have 100 grams of the sodium and you have 100 grams of the iron oxide, the question is how much solid iron in grams can we actually produce? So we're going to go through those steps on that last page. The first one is we are going to find out how much sodium, 100 grams, how much iron we can produce, and then the same thing, how much iron oxide, how much iron we can produce. So in our first one, our mass, mole, mass, you have 100 grams of sodium. And our first step, we need to go from mass of sodium to moles of sodium. So 1 mole of sodium over PT, 22.99 grams of sodium. Now once we're in grams, from grams to moles, we can go through our mole to mole ratio. In the end, 2 moles of iron is going to be to 6 moles sodium. So this point our grams have canceled our grams, moles of sodium have canceled the moles of sodium. And now once we're in moles of sodium, we can go our moles of iron. We can now go from moles of iron to grams of iron. Periodic table, 55.85 grams of iron is the same as 1 mole of iron from the periodic table. So numbers on top, 100 times 2 times 55.85 divided by 22.99 divided by 6. We're going to end up in the end with about 80.98 grams of iron if we started with 100 grams of sodium. Now our second one is we also have 100 grams of iron oxide, Fe2O3, and we want to see how many grams of iron we can produce from that also. So 1 mole of Fe2O3 is going to be the same on the periodic table as 159.7 grams of Fe2O3. From here, mole to mole ratio, 2 moles of iron over 1 mole of Fe2O3, our iron 3 oxide. And then our last step, going moles back to grams. 55.85 grams of iron is the same of 1 mole of iron. So in the end, grams would cancel grams, moles to cancel the moles. Moles cancel our moles, and we're left with about 69.94 grams of iron. Now, if we look back, 80.98 versus 69.94, the smaller amount is the one that's our limiting reactant. So when iron 3 oxide Fe2O3 runs out, the reaction stops. So our limiting reactant, the Fe2O3. It was the smaller amount produced. The other reactant then is our excess reactant. Our excess reactant, our sodium. Mass of solid iron produced, 69.94 grams of iron is going to be how much solid iron is produced. And our last part, how much excess reactant is left over. So how much sodium do we have left over? So to do that, we're just going to take how much iron we could produce during this reaction, and we're going to work back to how much sodium we needed. So if we had 69.94 grams of iron, we could go back mass, mole, mole, mass, and we could go 1 mole of iron from periodic table, 55.85 grams of iron. Once we're in grams of iron, or from grams to moles iron, we can do our mole to mole ratio, 6 moles, trying to find sodium, how much excess reactant is left over 2 moles of iron. And then we could go from moles back to mass. Periodic table, 22.99 grams of sodium equals 1 mole of sodium. Numbers on top multiplied, so grams would cancel the grams, moles to moles, moles cancel our moles, and we're left with 22.99 grams of sodium. Multiplying times 6 times that, divided by our numbers on the bottom, we end up with about 86.37 grams of sodium. That's how much would have been used during this reaction. Since we started with 100 grams of sodium, 100 grams of sodium at the top, 100 grams of sodium, this is what we started with, that's how much we have, minus the 86.37 grams of sodium is what we used. What we have in excess or left over, 13.67 grams, is what's left over. So if we think about that, mass of excess reactant that remains after the reaction, that 13.67 grams of sodium is our excess reactant. So we went through beginning mass of our reactants to produce how much product we'd have in each case. The one that produces the least amount is our limiting reactant. That limiting reactant then can be used to find out how much reactant we would need from the one that was in excess. How much we have of that excess minus what we used is what's left over. So iron 3 oxide, Fe2O3 is our limiting, sodium's our excess, how much product we would produce, and then how much left over. The next problem in your notes, you need to actually work through. Photosynthesis, we have our balanced chemical equation, 6 carbon dioxides to 6 waters produces 1 glucose and 6 oxygens. So during this reaction, you have 88 grams of carbon dioxide and 64 grams of water. You need to show your work to get to the answers. They are shown below. CO2 and H2O is your limiting and excess reactants. You'll produce about 60.1 grams of C6H12O6 or glucose, and you'll have about 29.7 grams of water as your excess reactant. You'll need to put the work to get those answers in the space provided and then show me. Just to end the chapter, or the end of the section notes, why we use excess reactants, this is just on the back page of your notes. One, to make sure the reaction goes to completion. Two, the cheaper or reactant you want to use in excess. And three, it speeds up our reactions as we talk about the collision properties later on. So that just wraps up 11.5. Make sure you just show me that problem when you get back to class.